Hi guys, we are going to have an asynchronous day. So you guys are going to watch the rest of this quiz review number 1 on video, and then I'm going to do quiz review number 2 on video as well. So to calculate C of H, the cost of a repair, a mechanic uses the function rule C of H equals 45H plus 30, where H is the number of hours. H is the number of hours it takes to complete the repair. And okay, this says it takes the mechanic 4 hours to make a repair. And what is the cost of the repair? So if I know that H stands for the number of hours, and I know that the mechanic takes 4 hours to make the repair, then what I'm going to do is put 4 in for H. I'm going to evaluate the function at H. So I'm going to say C of 4 is equal to 45 times 4 plus 30. I think I said I'm going to evaluate the function at H. No, I'm going to evaluate the function at 4. That's exactly what I'm doing. Evaluating the function at 4. So I'm going to say C of 4 is equal to 45 times 4 plus 30. And so C of 4 is equal to 45 times 4 plus 30 ends up being 210. So what does that mean in terms of the context of the situation? This means that the mechanic will charge $210 for the repair. And it actually is for the repair that is 4 hours long. Right? This means that the mechanic will charge $210 for the repair that is 4 hours long. Okay, next question. Will wants to buy a TV. He saved $50 last month and plans to save $10 a month until he saves at least $500. Write a function rule that models the relationship between M, the number of months he will need to save for his TV, and T of M, his total savings. Okay, so I look at this question and I think there's something that it says he wants to buy a TV. He saved $50 last month. Okay, so that $50 is like my service fee or my flat fee or my constant, right? Or my service charge. $50 is the amount that he has no matter what. And it says he plans to save $10 a month until he saves at least $500. Write a function rule that models the relationship. Okay, so if I want to write a function rule that models a relationship, it's telling me to use T of M and M. T of M is going to be his total savings. M is going to be the number of months. So we're going to say his total savings is going to be the amount that he saves originally plus his $10 a month. Remember we talked the other day about what is the constant and what is the variable part of the relationship, right? Or variable part of the function. And so the part that varies here is the months. It's the $10 a month part. So if I am going to write an equation that shows this, I'm going to say that T of M is equal to the 50 that he pays no matter what. That's his monthly, that's what he saved initially, plus $10 per month. And it turns out that this idea about saving $500 is kind of useless in the situation. You really don't need to have that information in order to answer this question. So this part about he saves at least $500, I'm actually going to take and strike through because we really don't need it. It's not part of the information that's necessary to solve this because all they're doing is asking for the function rule. Okay. So next question. It says Christina has saved $400 for a new laptop. She plans to save an additional $75 per month. An equation that represents her total her total savings as a function of the number of months she will save is S of M is equal to 400 plus 45M. Okay, so they give you the equation in this case, right? Now let's just compare that to the last question we just did. This one says that she saved $400. Saved $400 for the new laptop. And she's adding to that $400, $75 per month, just like the last situation. It's the $75 per month that's going to change, right? That's sort of the variable part of the relationship. Except now this one says Christina wishes to buy a laptop that cost $1,375. Okay, so which of these statements is true? There is not enough information to answer the question. Okay. S of 13 equals 1375, so it will take Christina 13 months to save enough money. Well, I don't know. Let's come back over here. It says that M is going to be, okay, actually it says an equation that represents her total savings as a function of the number of months she will save. That means that her total savings is a function of the number of months, right? So her total savings depends on her number of months. Well, if I look at this equation, S of M equals 400 plus 75M, I know that my dependent variable is going to be M, which is the number of months. So if I go down here and I read S of 13 equals 375, so it will take Christina 13 months to save money. I don't know, maybe that's true. Whoops. Maybe that's true. So let's figure out what S of 13 is and see if that is correct. I'm going to come down here. So if I said S of 13 is equal to, and I'm going to come back to this equation, the one that's up here, 400 plus 75M, right? But we know M is going to be 13 because we're evaluating this function at 13. All right, so S of 13 is equal to 400 plus 175 times 13. Okay, if I put that right into my calculator, in fact, I'm just going to open up another tab and figure it out. Ready? 400 plus 75 times 13. Let's see what that is equal to. And it says it's equal to 1375. Well, that's great because that's exactly what I needed it to be. I needed it to be 1375 because this says right here, S of 13 equals 1375. So it will take Christina 13 months to save enough money. That's great. Let's see if I can highlight this whole thing. Yes, I can, which means that this is a correct answer. Let's see if there's any others that make sense though. S of 1375 equals 1,003,525. That's actually saying that it's going to take Christina, well, okay, it's not saying that. This statement C is completely wrong. It's saying that it's going to take 103,525 months to save enough money. No. We know that her total savings is going to be $1375 because she's figuring it out for 13 months, right? She's not figuring out for if this part right here, S of 1375, says that you're evaluating the function for 1,375 months. But this is a lot more than what she needs, right? She needs to buy the laptop that cost $1375. So my correct answer for this is B. Okay, last but not least, this says Mrs. K is going to rent a car for 5 days. The rental charge is $79 per day plus 30 cents a mile per mile. She wants to spend no more than $500. Write a function rule that models the rental cost of the car as a function of the number of miles driven. Okay, great. Well, this one's a little bit tricky, and I'm going to tell you why it's tricky. It's tricky because Mrs. K is going to rent the car for 5 days. And they give you a rental charge of $79 per day. So even the best of us who want to write this function rule right away want to say that the initial fee is $79, but that's not true. The initial fee is $79 for 5 days. So I want to figure out, you know how we would talk about like having that initial fee or that service charge or that flat rate? All of that I want to figure out first, because then I know it's going to be plus 30 cents a mile. I don't know how many miles she's going to drive, but I know it's going to be 30 cents a mile. So let me figure out exactly what she's going to pay for a service charge. So then I can put my whole equation together. Okay, so I know, again, one more time, she's renting it for 5 days and it's $79 per day. Let's come back over here. I'm just going to open up a tab again. Here's my calculator. Let me get rid of this. And say, okay, if it's $79 per day times 5 days, let's see how much money that is. That's $395. All right, so let me go back to my review. I know that the service charge is $79 per day, but she's renting it for 5 days. That makes her service charge be, and now of course I forgot what it was. Let me come back over here, $395. Okay, so it makes her service charge be $395. Okay, great. Now let's write our equation. Now we're ready. We know that they're using C of M. So this is going to be the total cost. M is going to be the number of miles, right? My independent variable is going to be the number of miles. So C of M is equal to $395 plus 30 cents per mile. Let me see if I said that right, because I'm not recording this. Let me just say it one more time. I know that the service charge is going to be $395 plus I know that miles is my independent variable. I hope I said miles before. I'm not sure. I'm going to re-listen to it in just a second. But I hope I said miles is the thing that is variable in this situation, right? It's 30 cents per mile. So it's going to be $395 plus 30 cents per mile. There is the answer to my question. And I just want to point out, I'm not even sure I need to do this, but let me just say that if you were choosing a multiple choice question, right, and they had this as an answer, C of M equals 0.30 M plus 395, I hope that you would know that those two are exactly the same. Right? The one just wrote 395 first, the other one wrote 395 second. It's both exactly the same. Okay, I'm thinking that when I was actually doing this question up here, I was saying that the 13 was the dependent part, and I hope I didn't say that, but 13, anything in the parentheses always. We know this from, almost 3 Google Forms ago. Anything in the parentheses is the independent variable. 13 is the independent variable in this case. It's the number of months, right? That's the independent part. The dependent part is the answer, right? It's the total cost that that will be for the TV, or for that matter, the total cost of renting the car. Either way, both of those, that's the dependent variable. All right, thanks, guys.